All right, I'm going to go ahead and get started on this because I don't want to take all of our time on it. But what we're doing is we're taking our x minus 4 and dividing it into our 2x minus 6. That is when we divide our first and our first terms to get a 2 on top. That multiplies times this whole term over here to get our 2x minus 8. But remember, we talked about this a bunch yesterday. We need to subtract this and make sure we are subtracting. 2x minus 2x is 0x. That whole term should always cancel out. And then we have negative 6 minus negative 8. What's our remainder? Positive 2. Good job, Eric. So I'm going to write that in my little remainder fraction here, where we have our positive 2 over our, wow, that's really big. I'm going to write that 2 with a little bit less of a crazy size. That one, a little wonky. Positive 2 over our x minus 4. I write it into that mixed number format so I can come over here and just flip-flop those pieces to get 2 over x minus 4 plus 2. So that is our transformation form. Our transformation form is that 2 over x minus 4 plus 2. So that's what that is. Then let's find our a, h, and k. What's our a? 2. What's our h? 4. And what's our k? 2. So that means I have enough information to get my asymptotes. My horizontal asymptote, that's when my y is stuck. So my y is stuck at 2. It's been shifted up 2. Tells me my asymptote has been moved here. Our vertical asymptote, that's our x equals h. So in this case, it's x equals 4. And that gives us this asymptote here. Then we're going to take our parent function and apply our transformations. Our parent function doesn't change. So we should still have this from yesterday. This is our parent function, or last week. We used it a bunch last week. Then we're going to do our transformations. We're going to take our x values and add our h. So we're going to take our x's and add 4. We're going to take our y times a, so in this case times 2, plus 2. So when we take our x's and we add 4, we're going to wind up with negative 2 plus 4 is 2, 3, 4, 5, and 6. My negative 1/2 times 2 is negative 1, plus 2 is 1. This one's 0. This gives me my asymptote, 4 and 3. So then we plot up our points with our 2, 1, 3, 0, 5, 4, and 6, 3. We're going to make it hug the walls. Like this. questions on this part. Or on this, on the bell work, because that's all the bell work. Okay, so like I said, we're going to be adding in kind of our last piece for these rational functions with the graphs, because we've only had ones like this where it was a linear over a linear. But we've been working with all kinds of stuff that involves simplification and all kinds of things and maybe factoring. So we're going to see what it looks like when we have something that requires factoring. So we're going to work with something called a removable discontinuity. What a removable discontinuity is a hole. Literally like somebody took a line and stabbed a pen through it. It has a hole poked into it. So a hole, which is also called a removable discontinuity, is what happens when we simplify something out, when we have a factor that cancels out. So we're going to look at this equation here to see our first removable discontinuity. So what we're going to do is we're going to come into this equation here, our 2x plus 10 over x squared plus 6x plus 5, and we're going to try and simplify it. What we mean by that is I'm going to come through here, and we are going to factor top and bottom so that we can see what happens when we simplify. I'm going to give you guys a second to write all this down. All right, so let's take a look at these pieces. Looking at our numerator. What can I do to simplify this? Take out GCF. What's my GCF? 2. So I can rewrite this as 2 times x plus 5. It has a GCF. Then we're going to look at our denominator here. This one we're going to factor with our x. My a is 1, so I don't have to use the whole box, but I am going to need my x. My a times c is 5. My b is 6. What's a pair of numbers that multiplies to make 5 and adds to make 6? 5 and 1. So if you want to put this through the whole box, you can. But we also can see that this is x plus 5, x plus 1. What do we notice on that one? I can cancel out my x plus 5s. Those cancel out and give me a simplified form of 2 over x plus 1. Well, what that is that's my transformation form. I don't have any more x's on top. That's my y equals 2 over x plus 1. That's my transformation form. I have an a, I have an h, my k is 0. The thing is, when we have that x plus 5 that cancels out, what that does is it just gives us another place where our domain is 0, like our domain doesn't work. Because if I have some certain x value, it's going to give me a 0 in my denominator, and it causes problems. So the way we find our removable discontinuity is we take the piece we canceled out. So I'm just going to grab an x plus 5. Except I'm going to grab it green. And I'm going to write over here because my problem happens when that piece that was in the denominator, that x plus 5, when that thing equals 0, it causes problems. If it equals anything else, it's fine because they cancel out. But when it equals 0 in that denominator, it causes me problems. So when does x plus 5 equal 0? When x equals negative 5. Subtract 5 from both sides. So that is part of my discontinuity. We're going to write our discontinuities as a point. So we're going to have negative 5, that's my x. To find the y value of my discontinuity, I'm going to take my what's left over after we simplified. It is my transformation form in this case, but it doesn't have to be. And we're going to substitute that in. And it might still be a fraction, and that's okay. So what I'm going to do is I'm going to take and substitute in y equals 2 over negative 5 plus 1. So we're substituting it into the leftover equation. And then we're going to simplify that. Y equals 2 over negative 5 plus 1 is negative 4. And 2 over negative 4 is the same thing as negative 1/2. So we are going to have a discontinuity at the point negative 5, negative 1/2. So if it cancels out, we're finding an ordered pair. Questions on that new piece? Okay, our last piece here is to name our asymptotes, just so we get good practice with it. Our vertical asymptote, that's our x equals. What is our vertical asymptote here? X equals what? Negative 1. That's our h. It's the piece that's in that denominator. And our horizontal asymptote, that's our y equals, what's our k? 0. That's what we're adding today. Tomorrow we will put them on the graph as well. But we're just going to do the calculation part today, breaking it up into pieces for us. Questions on this first one? Okay. So when we have differing degrees like this, where I just have the one piece that cancels out, we will often wind up in our transformation form. Sometimes we're still going to have to use our division stuff. So we're going to look at one like this. And we're going to do the same thing. All right, so our first step is to come up here and try and factor and see if things simplify out. Whoa, hello. Okay, wow. Oh great, now my screen's freaking out. It's gonna freak out. There we go. Oh, we're back. There we go. All right, after a brief interlude, we're going to come through and we're going to try and simplify these. So looking at my numerator, what can we do? X is a GCF here. So we can take an X out, leaving us with X minus 4. In our denominator, what can we do?
We can take a shortcut since we
Mm-hmm. Since we don't have a b, and both a and c are perfect squares, this is a difference of squares. So this we write as x minus 4 and x plus 4. Doesn't matter which order it is, but yes. One gets a minus, one gets a plus. You can still do that with the x. Multiplies to be negative 16, adds to be 0. That'll be 4 and negative 4. Exactly what we have here. So what do we notice here? My x minus 4s are going to cancel out. So that leaves us with x over x plus 4. Well, it's not quite transformation form, but I'm going to find my discontinuity first. So the first thing we're going to do is I'm going all the way to the left over here, and I'm going to take the piece that canceled out, my x minus 4, and we want to know when that equals 0. Because when there's a 0 in my denominator, it causes me problems. When does x minus 4 equal 0? When x equals what? X equals 4. So that tells me the x value for my discontinuity. The way we're going to find that y is I can take even this one, even though it's not like all the way into transformation form, we can still work with this. And sometimes that makes it easier because then we don't have quite as many decimals. So I'm going to come over here and find my y equals and substitute in the pieces I know. I want to know what y is when x is 4. So we're going to do 4 over 4 plus 4. I'm substituting the red 4 in for all the places there was a blue 4, or a blue x. So the y value for my discontinuity is 4 over 8, also known as 1/2. So we're going to have a removable discontinuity at the point 4 1/2. Questions on that part? Because that's our new piece today. Okay, then we're going to get this into transformation form, just like we did with the bell work here. Since I still have a letter on the top, I need to do this as a division. So we are going to divide x by x plus 4. Yep, we're going to have a 1 on the top. Multiply that by the whole term on the left, and we're going to have x plus 4, which we are then, whoa, wrong pen. Then going to subtract. So we have x minus x, which is 0 x's, which is good. That's what we want. Nothing minus 4. Negative 4. Good. That's the same thing as having plus 0. So if it helps, put in that plus 0. You can always add 0. It doesn't change anything. Totally fine. So again, I'm going to write this into my remainder form up here, where I have my negative 4 up here and my x plus 4 underneath. Because my transformation form, what that is over here, is that's that guy on top of my division house just with their spots flipped. So we're going to have our negative 4 over x plus 4 plus 1. What is our vertical asymptote going to be? X equals -4. It is always X equals H, and our H is the -4. What's our horizontal asymptote? Y equals 1. Y equals K. K is added on the end. Okay, so we're just adding one little piece. There's about a gazillion pieces in these graphs, but we're just adding one little thing in right now. Let's do another one, because these are a little weird and it takes some practice. All right, in my numerator, when we just have an x squared like this, I can't really do anything, but we know we're trying to simplify stuff out, so I'm actually going to write this out as x times x. It makes it easier sometimes when we're canceling things out. Because in my denominator, what can we do to simplify? I have a GCF here of x. So this is x times x minus 9. Which means we can simplify out one of these x's. Which gives us our remainder, or our next piece of our function as x over x minus 9. Before I go any farther, I'm going to figure out the pair of my discontinuity. So the piece that we canceled out was x. X equals 0. So it's the piece we cancel out, and we want to know when it equals 0. Well, when does x equal 0? When x equals 0, right? So if we ever are canceling out just a letter, our x value of our discontinuity is 0. To find that y value, I'm going to grab my leftover piece over here. I know this is a y equals. So we're going to have our y equals, and we're going to substitute in our 0. I have 0 over 0 minus 9. Zero over 0 minus 9, so we have 0 over -9. What is 0 over -9? What's 0 divided by anything? 0. So our discontinuity is going to be right at our origin, right at the middle, 0, 0. It won't always be the origin, but it will not be uncommon. So then let's find our transformation form going through our division again from yesterday. So I'm going to take my x over x minus 9, and we're going to do this division where I divide my x by x minus 9. What's going to go on top? 1. Multiply that by my whole term on the left. Bring me x minus 9 under here. And then we subtract. When we subtract our x's, they cancel out, which is what we want. That first term should always cancel out. And then I have nothing minus negative 9. Positive 9, yep. So I'm going to, again, write this as my little mixed number, where I have my remainder of 9 over what we divided by, x minus 9. Which lets me switch it into our transformation form. We have our y equals, and that just means I put my fraction in the front. 9 over x minus 9 plus 1. What's our vertical asymptote going to be? X equals 9. And my horizontal asymptote? Y equals 1. So now we've done several of these questions. Okay, we're going to do one more. So I want you guys to think about it if you guys got questions, because these are a little weird.
My question is, how did you get that 0, like when the x equals 0?
I took the piece we canceled out, and I want to know when, sorry, laser pointer's being a jerk, when this piece equals 0. So I just took this chunk. I said, when does this guy equal 0? So I put that chunk here, set it equal to 0, and then I went, oh, sweet, I don't have to do anything. So just like we did on this one, I took the chunk that we canceled out, and I set that chunk equal to 0. Okay. You see what we did there, Levi? Okay, let's do one more. This one's a little bit harder. So we're going to have to do factoring on both the top and the bottom. So we're going to come over here and we're going to put everybody in our factored form. That's going to be our first step. So my numerator is going to take a little bit of extra work because we have this a value of 3. So I'm going to need my full x in box. I don't have a GCF I can take out either because I have both a 3 and a 5 as terms, so that's not going to work. So we're going to do our a times c, 3 times negative 12 gives me negative 36. And we want to know a pair that multiplies to make negative 36 and adds to make 5.
Oh, 9 and negative 4.
Yeah, 9 and 4 will do it. So we're going to have our 9 and 4. Which one needs to be negative? The negative 9. I genuinely could not remember what you said, so you probably had it right, but I just genuinely could not remember. All right, so then we're going to fill in our box. We're going to have our 3x squared from our equation, our minus 12 from our equation, our 4x, and our negative 9x. So we're going to pull our factors in columns and rows. So our first column here, we're going to have 3x, and our second column is a 4. Our top row, we have an x, and our bottom row, we have minus 3. So our factored form is going to be 3x plus 4 and x minus 3. Luckily, our denominator is not as complicated because this is very much like the one in the last one where we have a difference of squares. Difference of squares will show up quite frequently in this because we are being kind of nice. It saves you time and it saves you work. Because the difference of squares is one of those patterns. X's are in the front. It's 9 in the back, so we take the square root of 9, which is 3. 1 gets a plus, 1 gets a minus. That's our difference of squares. What can I do from there? The x minus 3's will cancel out. So my simplified form is 3x plus 4 over x plus 3. But before I go any further, I'm going to figure out where my discontinuity is, because I have a discontinuity where x minus 3 equals 0, because if I have a 0 in my denominator, it causes me problems. So I take this chunk that was in my denominator, and we want to figure out when it causes problems. So we set it equal to 0. X minus 3 equals 0 happens when x equals what? 3. So that is the turn the music down. I can hear it over here. Holy cow. I will come play Find the Headphones. Somebody really doesn't want to pass this class. Oh my gosh. Let's see, I get to go on a wander now. Oh, look, the music stopped. Yeah, I could hear that at my desk. So whoever just turned their music off, I could hear it at my desk. You're not going to pass your class if you're listening to your music bumping that loud in class. Rude. Not just to me, but to the people around you who might care about their grades. Because clearly you don't. That's what it says to me. Okay, let's finish out this problem. Oh my gosh. So we're going to find our y value by taking our leftover piece here and substituting in our x. We're going to take our y equals my 3x. So I'm going to substitute in my 3 plus 4 over my x, which is 3 plus 3. And we're going to get a fraction here, and that's okay. Because what we have when we simplify this, we're simplifying this in pieces. So I'm going to simplify the numerator, and we're going to wind up with 3 times 3 being 9 plus 4, and 3 plus 3. So I did my multiplication there. So that gives me 9 plus 4 is 13 over 6. And I'm perfectly content with you guys putting it as 13 over 6. You can also put it as a decimal if you really want to. When we get into the graphing of this, we'll probably switch it to decimals just to get an estimate. But I'm just going to put it as my 13 over 6. You have to know that one could be hard. Like, seriously. Oh my gosh, guys. We have 27 days left. Keep it locked in. We have 2 chapter tests between now and then. All right, let's get this into transformation form. So we're going to do the long division where we take our 3x plus 4 and we divide it by x plus 3. What's going to go on the top? 3. We're looking at that first term divided by the first term. That's going to give us 3x plus 9 underneath, and that's the piece we subtract. 3x minus 3x, those guys cancel out, and we're left with 4 minus 9. So what's my remainder? -5. So I can write this as my remainder format, where we have our remainder on the top and what we divided by on the bottom. So we're going to have our -5 over x plus 3. That's my transformation form once we flip their spots. We're going to have our -5 over x plus 3 plus 3. What's our vertical asymptote? X equals -3. And what's my horizontal asymptote? Y equals +3. Questions on these? Tomorrow what we'll do is we'll take these and we're going to graph them. We're not adding new, we're just going to graph it with the whole. The whole is the last piece we're adding to this. So that discontinuity is the last piece we're adding into the graphs. So what we have now is we have about 6 minutes or 5 minutes until announcements. So you can work on that same homework I gave you yesterday. I'm not giving you a new one today, and I'm not giving you a new one tomorrow. So on the back, they have some like this, where you can start doing our simplifying. We can start finding the location of the discontinuity. We can write it in our transformation form. Tomorrow, we'll go through how to graph it. It is not humongously different. Okay, so work on your worksheet. We have a chapter test next Wednesday, a week from tomorrow. And yeah, it's kind of the vibe. Happy Tuesday.